All right, we're going to see how to find this integral using numerical methods, trapezoid and the Simpsons method specifically. And we want to integrate from 1 to 4 the square root of 1 plus x cubed with 6 partitions here. So in the spreadsheet here, I'm going to write the function. So it's equal to 1 plus x cubed to the 0.5 power. That's the function that we want to integrate to the 0.5 power. And we're going to start somewhere. So I'm going to put a begin. Let's say call it A. A is going to be 1, and B is going to be 4. So my start is 1, my end is 4. And then there's a delta x, which I'm going to call H. H is my step size of, it's actually 0.5. How do you figure out H? H is equal to the width of the interval, which is 3, B minus A, divided by the number of rectangles, which is 6. So that's 1/2. So then some columns we're going to label. N is going to be the partition. So we started the first x value, initial x value is x naught, so we call it 0, 1, 2, 3, 4, 5, and 6. So, and then we want our x values, the actual x values. So the x values, well, the first x value is 1, where we're starting. The second x value is going to be equal to that one plus, you could say, this n value times your delta x. So you remember that right-hand sum formula we used. And delta x, you should fix that at that reference there. So put a dollar around the delta, the h, the 0.5 here. You know, there's dollars around d1. So when you do that, what's this going to do? It's going to actually, and actually, if we fix our a value, which is that one, if I pull this down, we get to 4. And this is exactly the formula, if you look, that we used in the right-hand sum for my C sub k. So anyway, and there's different ways you could just type the delta x, the x's, if you wanted to. So I'm going to highlight this anyway in a yellow. That's my x values. Now I want my f of x values. And let me bold this here. I'll bold the f of x. The f of x values are these. Is putting these x values into the function. So my first one will be equal, parentheses, 1 plus x cubed, but it's this cubed, so this thing cubed, and then raise that to the 0.5. So that's f of x. That's my first f of x. Once I do 1, I just need to drag it down. There's all my function values are the different x values. So maybe I'll highlight that too. So now we want to do the trapezoid method. And before we actually do the calculation of the trapezoid method, what we need is the function values for the trapezoid method. So remember, the trapezoid method said you take 1 times the first f value, and then 2 times the rest until the last one, you take 1 again. So in this cell, I'm going to go equal this previous cell, so I'm just retyping it. But the next one down, I'm going to go equal 2 times that f value, and I have to do 2 times each f value until the second to last one. So I just drag it. I just drag it down until the last one. The last cell is going to just be one of those f values. And so those are the function values for my trapezoid. And if I sum them up, so if I go equals sum, I get the sum of all the f values for the trapezoid, which is 51.64. So the trapezoid sum, what do? You take your delta x, which is 0.5, and you divide by 2. And I haven't finished yet on that. So you take delta x divided by 2, and then you times it by the sum of all those f values. And so that's my trapezoid prediction, 12.91. Now the actual value is about 12.87. So let's see what we could do with Simpsons. So Simpsons, what we do, again, in Simpsons, we want 1 times this f value, and then 4, then 2, then 4, then 2, then 4, then 1. So remember, Simpsons goes 1, 4, 2, 4, 2, 4, and so on, all the way up to a last 4 and then a 1. And all you need is an even number of partitions to do Simpsons. So in Simpsons, we take 1 times this one, and then we take 4 times the next F values, and then we take 2 times the next X value. So notice I'm referring to those cells. And once you do 4 and 2, you just need to drag that because there's a pattern that Excel recognizes. So I'll drag it down to the second to last one. And if you click on the cells, you'll see inside here 4, 2, 4, and then the last one is just one of those. It's just that f of x. So similarly, again, I'm going to sum those numbers up. So those are the function values that I want to just add up, and I've already multiplied by 4 and by 2. So this equals now this cell, the sum of these cells above it, and that's the trapezoid. That's the sum of all the function values. Now it doesn't look the same as trapezoid in the Simpsons. Sorry, this is for Simpsons, but that reason is what I'm going to take now is equal to my delta x over 3. Remember, it's not over 2 for Simpsons, times the sum of those values. I get 12.87. So if you look at that, I think that is much more accurate, right? Because the actual value, if you calculate it out, would be 12.87, close to that. So Simpsons is closer to the actual value than the trapezoid, using even only 6 rectangles.